begin. Now, just to warn you that this homework assignment today is going to take a little bit of time. It's mostly review. Nice thing. Let's take a look at the assignment first. Right here. It starts with just some basic GCFs. Nothing more. GCFs. On 18, you see there's 4 terms. That's when you're cued to use something called grouping. And when we get to something like this, a plain old trinomial quadratic, that's where you can use factoring, cream square quadratic formula for solving. This is just factoring, so we'll just use the x. And then when we get to 22, you can see that's a little different. We haven't done anything as far as factoring with cubes, and then when we get up here, we have to write it in quadratic form. I'll show you what that means. But it's things to the 4th power degrees of the 4th power, and then we're going to start solving. So, like we graphed these yesterday, 30, 35. We graphed 3rd degree and 4th degree polynomials, and you saw in the graph where it crosses the x-axis. You also noticed that sometimes they have one real root and they're too complex. Now we're actually going to get those exact solutions without graphing, just on these. And that's about it. A few things to look out for would be directions. So if it says just a factor, make sure you just factor, because the difference between factoring and solving is quite lengthy. Solving is going to take a little bit of time. That's why there's only a few problems that say solve. There's a lot of them that say factor. So when you see read the directions, make sure, especially on your test, it says factor, just factor. Don't spend another 5 minutes trying to solve it as well. Right. And then you'll get an eye for noticing, well, how can I write something as a quadratic form? How do I solve an x to the 4th as opposed to an x to the 3rd? What's the differences between them? How do I know how to see them? Okay. In general, there's going to be a different method for cubic, 33, 34, and 35, and then the 4th degree is 30, 31, and 32. Somewhat different, so you want to know both methods. And then, of course, when you see them, you want to know which method to use. So let's just start off with a little review. Just with the stuff that we've seen for years now. How do we let's just review all these stuff. So first step is always look for a GCF. I'm going to do these 4 evens from your homework. You'll do the odds and check your odds. They're just review, so we'll make sure we know how to do it. But the first step is always look for the GCF. So what is a GCF here for both variables and numbers? Always remember to do that on every single problem. It's going to be easier and easier to forget the further we get along. We're going to be wanting to getting to this, new methods and what we have to do. Sometimes it's easy just to overlook the obvious. So we're left with answer. Okay, not too bad. And that's considered factoring. A GCF, greatest common factor, if you take it out, is considered factoring. So some people will say, well, I only did a GCF, so it's prime. Like, I didn't do the x, so I didn't do anything else. No, that counts as factoring. So
you're done after that?
That's done. Yeah, we can't factor this inside. This is basic review. What's the GCF of 16? Numbers and variables. So just do the numbers first. So what goes into 12, 8, and 10? 2. Okay. And then for the C, what degree of C?
C squared.
C? Yes. You have to go with the lowest one. It has to be in all of them, but then you pick the lowest. And then what's the lowest of these?
B
squared. So there you go. And then work backwards to see what goes inside the parentheses. Remember, 2cd squared times what equals 12cd to the 3rd. What goes next? 4 C. Okay, and the next is 5 C to the 4th, D to the 1st. Good. And we won't see too many like these, which is good. What about here? Any GCF? Yeah. You might look at the first three and say, I had 2, but then there's a 9 there, so that doesn't work. The last 3 works in all of them, but 3 doesn't work in 8. You think, okay, Z, there's no Z here, you know. So what happens when there's no GCF and you have 4 terms? But you can see that there's a Y and a Y and a 2 that can come out of, or Y and a Z, or 2 and a Z that can come out of these 2. And maybe a 3 that can come out of these 2. So there is some GCF, just not the whole thing. It's a good hint if you want to throw it into the box and just do it by, it's called grouping. So you take each of these, throw it into the box as if we're factoring. And do the GCF, what we just did on 14 and 16, just do that for each row and each column. So what do we get here? What's the GCF of just the first 2? Say earlier, that's 2Z. What's the GCF of the second row? 3. Okay. GCF of the first column. And we get 4Y. And also, this times this had to equal this. Does that work? 4Y times 2Z, does that equal this?
Yes.
Does 4Y times 3 equal this?
Yes.
No, negative.
No. So let's fix this, put a negative on the 3. Likewise, we could just say, GCF of this column, or we could say 2Z times what is negative 6Z. And then check the last box, is negative 3 times negative 3 equal this.
Yes.
So there's our 2 binomials. 4Y minus 3 and 2Z minus 3. In no particular order. So with 4 terms, use this grouping method. 4 terms. And number 20, the last one, you guys know this very well. Big unit on it. How do you factor this? Where's the factor? No number in front, so that makes it even simpler. Well, 2 numbers multiply to 4, but add to negative 5.
Negative 4, negative 1.
Negative 4, negative 1. And our front is going to be this y. So, y minus 4 and y minus 1. So like I said before, all grouping. Stuff you've seen before, know very well. We're going to be using it at any given problem. Any of this stuff can show up. We'll have a GCF, we'll have, maybe use a box. We'll be using the x if it's factored. Remember, not every trinomial factors this way. So if this didn't work, we'd have to go to between a square or quadratic formula. Alright, so that's the first part. You guys are going to need to check your answers. Next, we'll get to 22 and 23 for factoring. You also see down here, there's some more that are cubed, 33, 34, and 35. So I'm going to give you some generalities about how do you solve these cubes. And these are all special. You can tell they're kind of set up a certain way. Okay. They're all something cubed, and then plus or minus some number. Now these numbers you're not too familiar with. To me, they're very obvious numbers. But if I ask you, well, what are these numbers right here? Right? What are those numbers? Square roots, right? Or perfect squares. So, but what about these? Those are perfect cubes. But it's not quite as obvious. It's not. I'm sure you're not used to saying, oh, 8, that's 3 cubed. You know, right there. Or 125, that's 5 cubed. Or 27. Okay, that's 3 cubed. Or 1, I guess we could both these have 1. 1 cubed is just 1. So you see, 27s and 1s, we're going to start thinking those are perfect cubes. 8's 27. Again, perfect cubes. So after a while, you see these perfect cubes staring right at you. That's a sign that you need to do something special. So let's show you what that is. So first, let's review difference of squares. So x squared minus 4. Well, how does that factor? X minus 2, x plus 2. Or x plus 2, x minus 2. And the way we looked at this said this is a difference of two things, two terms being squared. So it's just going to be one of them with a plus and one of them with a minus. And that is the difference of cubes. And what about for different sum of squares? Squares. Could we do this? Could we factor x squared plus 4? Does that factor at all? And we said no. It had to be a difference. For the squares, it has to be a difference. So sum of squares does not factor at all. Now, what if we have cubes? So x cubed, let's say, minus 8. How does that factor? Okay. So, first of all, we have to recognize, well, this is indeed a difference of cubes. This is x cubed minus what? 2. And you do want to write it like this form. I know up here we got used to just not really writing this step right here. We can say, oh, x squared minus 4, x plus 2, x minus 2. On these, you really do want to write it. Okay, now here's the thing. It's a little bit longer. It factors to a binomial times a trinomial. The first binomial is the same, just without the cubes. And it's also, one thing important to note is that it's the same sign. Same sign. So if this is negative, this one's negative. If this was positive, this one would be positive. So they're always the same sign. So I'm really giving you the steps for both the difference of cubes and the sum of cubes. What goes next? So there's 3 terms here, right? 3 terms. The first one is going to be whatever is here, and then squared. So yeah, it's going to be x squared. And what about the sign? It's going to be the opposite. So that's what we have plus. Then we multiply these 2 together. Without the cubes, just multiply them together. We have x times 2. And lastly, just like the front one, we just squared x. The last one, we're going to square the last part. So we get 4. Is it positive or negative? This is actually always positive because we're squaring whatever this is. So it's always going to come out to be positive. So we have the same, opposite, and always positive. So some people that helps them remember about the signs and everything. And for the first one, the same, it's actually the same as whatever you're starting with. So it's x cubed minus 2 cubed. So this is x minus 2. Same. The same expression, same sign, and then we go to opposite. These 2 are just the squares. Square the first one goes first in the trinomial. square of the last one goes last. And the middle, you just multiply the two. So x and 2, x and 2. And it is nice because this same acronym, the same process works for a sum. So what number is this cube? 4. Yeah, that's 4. Got to know. Multiplies to a binomial, then a trinomial. You know what I like to do? I like to set it up, get everything there. If you want, you can even put the signs first. So this one's going to be what? Same, right? This one's plus. This sign will be opposite. And the last one is always positive. Have the signs. What about the terms? Okay, so x cubed plus 4 cubed, so the first one is just x plus 4. Square the first term, we get x squared. Multiply these two together, you get 4x. And the last term is, last one squared, 16. We do have a difference of cubes and a sum of cubes. We don't have a sum of squares. We have a difference of squares. So. Well, that's the workings behind any time we have cubes. First, we have to recognize that, okay, this is 5 cubed and this is 2 cubed. What about one of these? One that we have to solve. Let's do one that we have to actually solve. It'll be a little bit more work, but that's okay. Let's do, let's do 34. First, we can't solve the way it is. That's why we need the factor. So let's write this as cubed. So what is this? What cubed equals 27x cubed? 3 what? 3x. And then we have this 1. So let's write it as cubes first. So binomial. Trinomial. What goes in the first binomial? What is it?
3x plus 1.
3x plus 1. So it's the same, just without. Next, square this in the parentheses. What do you get?
3x squared.
Close.
Oh, 9.
9x squared. Sign is minus. Same. The opposite. What goes next? 3x times 1. 3x. What goes last? 1. Plus 1. Now 1 squared equals 1. Always positive. So now, and this is equal to 0. So let's solve. So let's solve each one of these. So we have 3x plus 1. That equals 0. So 3x equals -1. So x equals -1/3. So without actually graphing, we know that this will go through the x-axis at -1/3. Now what about here? How do we solve this? Any ideas? Quadratic. Complete the square or factor it or quadratic formula. Yeah, we take a choice. We're not going to graph it, obviously. So, complete the square might be a little ugly because we have a 9 here. We'll have a bunch of fractions floating around. And if you try to do the factoring, it won't work. Put two numbers multiplied to 9 and add -3. It won't work. So yeah, we have to do the quadratic. Yeah, within this whole problem, we have to go ahead and do another whole problem of quadratic formula. All over. 2 times 8, 9. Now here's the thing. If you don't do the difference of, or the sum of cubes correctly up top, you'll have the wrong quadratic here, and then all this work will be for nothing. Figure out, hit print 1 time or 2 times, and it's not working.
That's cool.
Alright, so let's complete this. There we go. So you get 3 plus or minus. What is the discriminant coming out to? 9 minus 36 all over 18, which equals 3 plus or minus root -27 all over 18. Simplify it all the way. What does 27, root 27 reduce to? And of course, reduce all these by 3. 3 goes here. That's 1 plus or minus I root 3 all over 6. So there's our other 2 complex roots. Could say it's 1/6 plus 1/6 plus or minus root 3 over 6 I. So there's our 3 roots, 2 roots here, plus or minus. And our third root was what we got up here. Right? And those were all 3 roots to our cubic equation. Okay, I have 3 total. But yeah, that's why I said earlier, it's a big deal. If it just asks you to factor, this is all you need to do. Is this up here? That's factoring. Solving could involve you doing a whole quadratic formula. So you don't want to do all this work when it just says just the factor. Good. You guys will have some fun with that. Lastly, just for like 24, it's just asking you, can you write this in a quadratic form? So here's a good example. Can I write this in a quadratic form? Basically, you're looking for a trinomial. Okay. And the exponents have to be similar. You know, in a regular quadratic, like this. Notice how that the leading term has an exponent of 2, the following term has an exponent of 1, and this one is twice as big as this one. And if you have that relationship with one of them, I'll just say if you have that relationship, you should be able to work this out well. So really what this means is that can we solve this in the same way? Oh, we just need to factor this. No, just write it. All we have to do is write it. Okay. Basically, can we write this as a quadratic term? Let's just go. So this could be written as 4, 2, okay, 2x to the 4th. Okay. All of the GCF. So first step would be take out a GCF, 24, and we'd have x to the 4th plus 3x minus 5. And then from here, we're saying, well, can we write this as squared? Yeah. Right like that. So get that here. Alright. Pull that forward. Can they be written in this format? Run low at times, I just want to show you a little bit of the work. So you want to write it as something squared. Just like a quadratic, is the first term is squared, the second term is raised to a power. So first term is squared, so it's really an x to the 4th, but same thing here. Always do the GCF first. And then the x, the b to the 4th, we can write as b squared. So what we're going to end up doing is using this to solve. Even with these kinds of problems, like that 29 where it says x to the 2/5, that's the same as x to the 1/5 squared. So they have the same format as a quadratic equation, and then you can go backwards the same way. When we get to 30, I'm just going to tell you to use the x and do it the same way you always would. So what two numbers multiply to 225 to add to negative 34? Use the x, but instead of getting x minus this, x minus that, you'll get x squared minus 9 and x squared minus 25, and you can solve them both. Right here. So just do the same thing we always do. What two numbers multiply to 225? Add to 34, negative 34. Right, so we get the minus 25, negative 9. But instead of just having x and x, we'll have x squared. X squared. You have to solve both of those to get your 4 total answers. So just treat it in the same way. We'll go over why this works later, but we're going to have time today. Same thing over here. What two numbers multiply to 16 but add to negative 15? What two numbers multiply to negative 27 but add to 6? And then you'll have x squared. Okay, instead of x is x squared, and you'll solve each one of those equals 0 and get your answer. Okay, this is going to take a little while. Do as much as you can. But we'll have about 20-25 minutes tomorrow at the beginning of the class to finish it up. We're going to have a lot of questions. So work on as much as you can, use the internet as a resource, and we'll come back here tomorrow to finish it up, all right?